One more example where we're going to work on finding the area of the region in polar equations. This is a bit challenging example because look at those beautiful graphs. So the first graph, I used Wolfram Alpha to do this graph. 9 sine 2 theta. That is the graph of the rose with 4 leaves. When 2 is even, number of leaves doubles, so we have 4 leaves. But the other one is just a circle lifted up. At 0, it is 0. Then at pi over 2, it's 9. So it goes up till 9, like so. And basically, it's a huge circle. Let me beautifully create a circle for you. Look at this. Amazing. Amazing. So they want us to find this area. Intersection. We have 2, so let's find the one in yellow and then multiply by 2. So let's find the one in yellow on the right. As always, we start with finding points of intersections. So these are the points, right? To find points of intersection, I will set those two equations equals to each other because it's a system. R equals 9 sine 2 theta and R equals 9 sine theta. It's a system. When they intersect, they give you points of intersection. So 9 sine 2 theta equals 9 sine theta. Divide by 9. You have sine 2 theta equals sine theta. They cannot cancel out because they have different angles here. So we're going to use the formula of double angle for sine. The formula says that sine 2 theta can be written as 2 sine theta cosine theta. That's actually half angle formula. Equals sine theta. And yes, we assume you know this formula. If you don't, now you do. Put it somewhere in the list of formulas you need to know. That comes from trigonometric classes. Okay, so you want to cancel out sine theta and sine theta, but remember, you cannot divide by 0. By canceling out like this, you're losing one of the roots. So remember, theta is 0, and then pi, and 2 pi, and so on. We will only need 1. Was already counted, and only when we decided not... My cat is getting crazy. Only when we decide that it's not 0, we can cancel out. Now we have 2 cosine theta equals to 0. That takes us to, not to 0, I'm sorry, 1. That's a pretty important mistake, actually. Not to make this mistake. Sine over sine is 1. That takes us to a very classical angle, 1/2. Cosine of what angle gives you 1/2? Well, many of them. But we will only ask for first one, which is pi over 3. So now we have 2 angles we need. The first ones, 0 and pi over 3. Let's write it down. Theta is 0. Theta is pi over 3. Let's go back to the picture and see if it makes sense. It better make sense, or else. So at 0, the object starts. Then at pi over 3, we have this point of intersection. This is what we found. Theta equals pi over 3. Theta equals 0. So the area we're going to find if we start building the integral from 0 to pi over 3 will be this area. That will be area 1. So let me do steps. Step 1, find points of intersections. Points of intersection. Step 2, figure out what areas we're actually looking for. Area 1, and we remember the formula for the area. 1/2 integral from alpha to beta, 0 to pi over 3, r squared d theta. And we will decide later what r goes inside. This will be the first area in blue. The area in green continues. That's the other part of the leaf, and it's not half of it, so we cannot just double and move on. This area will be from the angle pi over 3 to, guess what? Exactly, pi over 2. So the second integral will be from pi over 3 to pi over 2. area 2 will be 1/2 from pi over 3 to pi over 2 r squared d theta. Now let's carefully decide which function to use where, because we have different functions. 1/2 integral from 0 to pi over 3. Let's see, are we walking on the circle or are we walking on the leaf? Well, red color is a circle, right? Let's make it pink and fat. So this will be a circle graph. And the circle graph is r equals 9 sine theta. So that's the one goes into the first integral. 9 sine theta, d theta. Is anything missing? Good job. Square. Don't forget that. The second area will be 1/2 integral from pi over 3. So it continues from pi over 3, finishes or completes at pi over 2. Now let's see where we're walking on. Are we still walking on a circle? Now we're walking on the leaf. We're walking on the leaf. So basically we started walking on the circle like so, right? We walk, walk, walk. And then we switched direction and came back to 0 on the leaf. And that's why to calculate this area we need to use a different function. This function is 9 sine 2 theta. 9 sine 2 theta. Look at this amazing color coding. So proud. And as you guessed, we're gonna add those two together, and that will be only one leaf. So don't forget at the end to multiply. So it's called A, and then the answer will be A, 2A basically, 2A. So we'll multiply because we have two leaves. That's it. So now you can go ahead and finish this problem by yourself. I will do it for you, don't worry. But maybe it's nice if you practice integration by yourself, especially if exam is coming. So step 3, actually calculations, right? So this was a setup. Maybe I should make a point. Remember, we're looking for two leaves and not full leaves. They're actually like this, right? This one and that one. So when we found one, we'll multiply by 2. Okay, actual calculation. A1 will be 1/2 integral from 0 to pi over 3, 81, and then sine squared. How do we integrate sine squared? Exactly, we'll write it down as 1/2, 1 minus cosine 2 theta. Double angle formula. That came from pink, 9 sine, here it is, 9 sine theta. And now quickly integrate step by step, piece by piece. So 1/2 and 1/2 actually gives you 1/4. So it's 81 over 4. 1 gives you theta minus, and then this is your substitution to theta. I know a shortcut. Integral of cosine is sine plus sine, right? But minus was in front of it. So it's going to be sine 2 theta over 2 divided by the leading coefficient, or just perform your substitution from scratch. Bar from 0 to pi over 3. Luckily 0 makes everything 0 because sine of 0 is 0. So we only need to care about the number pi over 3. That will be pi over 3 minus sine 2 pi over 3. 2 pi over 3 over 2. The final answer is, so they are simplifying, I can see, blah, 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 81 over 4, over 3. So 81 and 3 cancels out. It becomes 27 over 4 pi. Again, you don't have to cancel it out, but since I see solution in front of me, why not? Then I have 81 over 16 square root of 3. Square root of 3 over 3, remember? So that is the first answer, area number 1. Quickly integrating second integral. Second integral is 1/2 integral from pi over 3 to pi over 2. And then we have 9 again, so it's 81. Sine square, again, I'll put it in purple color, will be 1/2, parentheses, 1 minus cosine. But now it's not 2 theta, it's 4 theta. Because it was 2 theta originally, and we do double angle formula, called also power reduction formula, because we're reducing from square to 1 power. Integrating that, exactly the same idea. So maybe it should just give you the answer, because there's nothing new here. Integral of cosine is still sine, just divided by 4 in this case, not by 2. Oh, so I think that's what I copied wrong. No, everything is correct. So the answer will be blah, blah, blah. Collect all the terms, 81 over 4, one more time, blah, blah, blah. It will be 27/8 pi minus 81 over 32 square root of 3. So you know at pi over 2, sine of pi over 2 times 4 becomes 2 pi, that is 0. So again, we only actually care about this pi over 3 number. That's the only one that does not give us zeros. So add those together. They actually do add up nicely. 27 over 4 and 27 over 8 adds up nicely. So area becomes, let me put some bullet points. Bullet point. Area is A1 plus A2. Simplifies to 81 over 8 pi. And square root of 3 also adds up nicely. Minus 243/32 square root of 3. Amazing. Wonderful. My new favorite word. Wonderful. This is just wonderful. The answer will be just double this result. Answer for this was 1 leaf, right? 1 leaf. Interesting that leaf, we're using F, but many leaves using V. So 2 leaves will be 2 multiplied by A. And if you want to simplify that, 81 over 8 times 2 simplifies to 81 over 4 pi minus, and 32 times 2 simplifies to 16. So 143 over 16 square root of 3. That is the final answer, which you can actually find the approximate answer. This is area, remember, it's like some kind of actual physical object. Positive units squared. Good job for watching. Remember, plotting the graph is pretty crucial in cases like this. So knowing how it looks like, knowing that we have first 4 leaves, 1 leaf per quadrant, and then a circle, and then each leaf, even though each piece is the same, they did not divide exactly into halves, and that's why you need to go through cases. Case number 1 was from 0 to the angle, points of intersection, and case number 2 was from 0 to pi over 2. And then you multiply by 2, the very last answer. Good job for watching. Have a good day. Go get some ice cream and go feed your cat.